So we have learnt about what is heterogenic catalytic reaction and how this reaction is taking place through contact theory. So in contact theory, we have seen about 4 steps. First step is adsorption step. Second one is formation of activated complex. Third one is decomposition of activated complex. Fourth one is desorption of products. So through these 4 steps, we are getting a final output from a molecule that is called ethylene in the presence of catalyst, that is nickel. And we are getting an output that is an ethane molecule, CH3 bond CH3. So why we are telling this is an heterogeneous catalyst is the catalyst here what we are using here is in a solid form, remaining all the reactant and product will be in a gaseous state. So in contact theory, we have seen how this reactant is undergoing a reaction with the presence of a nickel catalyst and it is forming a product that is in a gaseous condition, that is ethane. So apart from this, we have learnt about many industrial process, how in industries they are using this catalyst to prepare a huge amount of material. So first process we have learnt, that is a Haber process. So in Haber process, we have prepared ammonia in large amount in the presence of catalyst, that is iron. And second one, we have learnt how the hydrogenation reaction is taking place to convert vegetable oil to vanaspati in the presence of catalyst, that is called nickel. Third one, contact process. In contact process as well as in chamber process, we have seen the preparation of sulfuric acid in the presence of different catalysts. One is vanadium pentoxide, another one is nitrous oxide. Then the fifth industrial application, what we have seen is preparation of nitric oxide by using Oswald's process. So in Oswald process, what we have prepared is the preparation of nitric acid in the presence of catalyst, that is platinum. Sixth one, the reaction is Bose process. In the Bose process, we have prepared hydrogen in large quantity by using a high temperature, that is 1000 degrees Celsius. We are going to heat coke and it is we are preparing out how much of hydrogen has been prepared there. So next one, we are going to see about another one process that is called Decaun's process. In this Decaun process, the preparation of molecule in large amount is chlorine. So this chlorine has been prepared in large amount in the presence of catalyst that is called copper chloride. So in this Bose process, we have used a catalyst that is called iron oxide. Then eighth one, we have seen about the synthesis of methanol, synthesis of ethanol, so this here the synthesis of methanol, it is again we are getting from this carbon molecule. So here the reactant what we are going to use as a catalyst is zinc oxide. So in the preparation of ethanol, two different methods was there. One is preparing ethanol from a normal ethylene molecule. How this ethylene molecule is converted to ethanol in the presence of phosphoric acid. So here this phosphoric acid is acting as one of the catalysts and it is giving an output that is an ethanol molecule. This is one of the great industrial process to prepare the ethanol. Another one process is the same ethanol we can use by using an enzymes, that is a normal glucose molecule we can take. So this glucose molecule when it is reacting with an enzyme, that is a cymase, that is an enzyme name. The cymase when it is reacting, it will be providing a compound that is ethanol outside. So this is also one of the major manufacturing process taking place in the industries to prepare different materials. Okay, so we have seen about different industrial process. So following that, the main application of this catalysis is we are using the catalytic converter, that is one of the large chamber which is converting the toxic material to the non-toxic material. So here we are using a chamber that is a metal chamber. So to the metal chamber, here the exhausted gas from the internal combustion engine which has been having a high toxic material, that is CO, carbon monoxide. So this carbon monoxide has been removed by a chamber which is undergoing a principle that is called redox principle. So in this chamber, redox reaction will be taking place. The redox reaction means nothing but reduction as well as oxidation will be taking place to remove the unwanted toxic material. So in this chamber, the exhaust gases will be going inside to the particular chamber. In the particular chamber, there will be a two compartment. One compartment will be undergoing reduction reaction. Another compartment will be undergoing the oxidation reaction. So this compartment A, this is called compartment B. So it will be attached like this. So in this chamber, this gases will be going inside and it will be getting accumulate on this chamber. In this chamber, the metal rhodium as well as metal platinum will be there. In this compartment B, platinum as well as palladium will be there. Here it will be undergoing reduction reaction. Here it will be undergoing oxidation reduction. So finally the gases coming out of this catalytic converter will be free from all pollutant. The main pollutant what we are removing here is CO. So we can remove this CO by using this catalytic converter. So here what is the behind principle is the catalyst is having major power in the role of synthesis as well as a purifying agent in the environmental sector to remove all the hydrocarbon derivatives. So hydrocarbon derivatives mostly in fuels, we are using this hydrocarbon as a fuel. Example, it may be propane, butane, what we are taking as a diesel and petrol. So the diesel and petrol will be holding many amount of pollutant. The most of the hydrocarbon which will be converted to CO2 as well as a moist but in some condition it will emit some of the toxic material, that is CO. This toxic material can be removed by using this catalytic converter. So this catalytic converter is nowadays is having a major role in removing all the pollutant from the hydrocarbons, that is the diesel and fuel, and it is providing good support to the environmental side to remove all the toxic substance. So basically in this adsorption class we have learned that the adsorption power is more. Reason is the taking place of inside the reactant molecule, and it is undergoing certain changes, and finally it is leading out as a product by removing the catalyst more easily. This is a process taking place in the adsorption studies. So this adsorption studies, it will be having many impact on certain factors. This adsorption can be changed based on certain phenomena, that is we can tell factors affecting the adsorption. Factors affecting the adsorption. So what are the factors will be affecting the adsorption? We can tell us first one, the nature of adsorbent. Adsorbent is nothing but it is a solid material. So the solid material, it is acting here as a catalyst. So this catalyst should be having a distinct nature. So this distinct nature will be having certain pores in it. We can call that as an active sites. So what is the role of this pore, that is an active site in the adsorbent? The adsorbent means the adsorbent will hold many reactant molecules on its surface. So based on the pores and active sites, n number of molecules will be going and attaching on the catalytic surface. So in the catalytic surface, the molecules going and attaching there, that is maybe a gas molecule, or it may be, we can call this gas molecule as adsorbate. So this material is called adsorbent. So this material is called adsorbate. This adsorbate will be holding on the surface, and this phenomena is called as adsorption. So first initially we are telling that the adsorption can be disturbed, or it can be changed, or it can be increased, or it can be decreased based on the nature of the adsorbent we are using. Second one, we can tell the nature of adsorbate material. The adsorbate material, in this adsorption study, we are going to see only about the gases, or we can tell a suspended material. So what is this two things? This gases, there is a natural gas, it can be hold on the surface only to a particular limit, but we can tell there is an liquefiable gases. So this liquefiable gases is nothing but NO2, SO2, these sort of gases can easily bind with this adsorbent material. The reason is it is having many sort of power of attraction inside. Okay, then third we can tell us, we can convert our adsorbent, that is adsorbent material, as an activated adsorbent. So normally we are having an adsorbent, it may be one catalyst. Our role is to convert this adsorbent to a activated adsorbent material. Example, we can tell charcoal. So the charcoal will be having the ability to absorb some of the gaseous molecule, we can tell this carbon tetrachloride. So this carbon tetrachloride, when it is a normal charcoal, it will absorb only to a limited amount, that is 0.011 gram on it. But when we are converting this charcoal to one activated charcoal, or we can provide heat, a steam to that, and we can create an activated charcoal. This activated charcoal will be having more pores on it, and it will be having more active site on it. So based on this, the same carbon tetrachloride will be captured in large amount, that is 1.48 gram can be captured on it. So this is the third factors, we can enhance the adsorption rate. Then we can tell about the pressure as well as temperature. pressure and temperature. So the pressure, what is the role of pressure is, the pressure, it can be inversely proportional during this adsorption, and when we are taking temperature, this temperature will be directly proportional. So this may vary based on physisorption as well as chemisorption. So based on this, when there is a change in pressure, there will be a particular condition, the temperature will be constant. When there is change in temperature, the constant will be pressure. So based on the constant temperature, there are different sort of isotherms exist there. One is, we can tell about Freundlich Langmuir. So these are the different sort of factors which is affecting the role of catalyst. So finally, as a conclusion, I can tell that the catalyst is taking a major role in, by basing to prepare many sort of industrial materials, many sort of a product can be synthesized by using the catalyst, and by following a contact theory, it can clearly explain how this reactant molecule is getting adsorbed on the surface of the catalyst and how we are getting out the product. At the same time, we can go through that the catalytic, it has been taken role in the environment to remove all sort of pollutant by using a catalytic converter chamber. It is one of the best application by using the this adsorption as well as catalytic study. Thank you.